So this week we looked at ANOVA for comparing between 3 or more groups. You may be asking yourself, why don't we just do multiple t-tests? This video is going to show why that's a bad idea. In order to understand the problem, let's first remind ourselves about the meaning of p-values. A p-value of 0.05 tells us that if we ran an experiment many times, we would expect a difference this large between the control and the treatment in 5% of experiments, even if our treatment actually had no effect. This means that there's a 95% chance any result is not simply random chance. If we do multiple t-tests, then our chance of getting a false positive increases with the number of tests. A false positive is when we detect a difference which isn't really there. With 2 t-tests, the chance of a false positive is 9.75%. This graph shows the relationship between the number of t-tests and the chance of a false positive. Where we have 14 or more t-tests, we have a greater than 50% chance of one of those tests returning a false positive. After we run our ANOVA, we often want to run a post-hoc test to look for differences between treatments. Post-hoc tests adjust for these problems, which allows multiple comparisons. Each test corrects the data in a different way, and they all have their own strengths and weaknesses. Tukey's test is essentially running multiple t-tests, but it compares the t-values to a different distribution called the Q distribution. The Q distribution is more conservative than the t distribution. A more conservative test means you're less likely to make a type 1 error and less likely to find differences which do not really exist. So are there any downsides to using post-hoc tests? Well, post-hoc tests can lack statistical power, and it may be difficult to find small but real differences. In other cases, however, post-hoc tests can be more sensitive than ANOVA, so it's often worthwhile to run the tests anyway and try to interpret the data using your brain.